We begin with multiplication of a vector by a scalar. When you multiply a vector, a, by a scalar, this multiplicative factor just rescales the magnitude or the length of the vector. Let us look at the vector 2 times a. This is in the same direction as the vector a, but is twice as long. This is vector b. A vector is defined by its magnitude and direction, so this vector b is the same anywhere in space, including at the origin. If I want minus 0.5 times b, this vector is in the opposite direction of b and is half the length. Now let's look at vector addition. Here's a vector a, here's b. How do we add them graphically? We slide the tail of b to the head of a, and their sum is a vector drawn from the tail of a to the head of b. I could have also added a to b by sliding the tail of a to the head of b. You can see that this makes a parallelogram, and the sum, vector c, is just the diagonal of this parallelogram. Subtraction can be thought of as just multiplication and addition. If I have c is equal to a minus b, I just need to add a to the vector minus b. Minus b is negative 1 times b, which is this vector here. Now I only have to add a to minus b. Let's do another example. Here my vectors a and b do not start at the origin, but since vectors are the same anywhere in space, I can go through the process here. I want a minus b, so I first multiply b by minus 1 to find minus b, and then I move the tail of minus b to the head of a and add the two like this.